Welcome to the Stats Corner. In this video, we are going to discuss one of the important questions from generating function. These questions appeared in ISS 2024 examination. This is not only useful for ISS but for other examinations also. So what the question is saying? The question is saying that let x1, x2, xn be a random sample from normal mu comma sigma square distribution and the quantity s square equals to 1 upon n minus 1 summation xi minus x bar square where x bar nothing but the sample mean. Then what is the moment generating function of s square? We are asked to find the moment generating function of s square. Okay, so what we know that if we transfer this n minus 1 this side, then we'll get n minus 1 s square equals to summation of xi minus x bar square, right? Now, if we divide both sides by sigma square, then that will follow chi-square distribution. So n minus 1 s square upon sigma square equals to summation xi minus x bar upon sigma whole square. This quantity follows chi-square distribution with n minus 1 degrees of freedom. Okay. So we can say that this n minus 1 s square upon sigma square follows chi-square distribution with n minus 1 degrees of freedom. Right? Now, if ask you that if x follows chi-square distribution with n degrees of freedom, then we write x follows gamma distribution with half comma n by 2. Is it correct or not? Correct. So the degrees of freedom will be divided by 2 and the rate parameter will be half 1 upon 2. Similarly, we can say that n minus 1 s square divided by sigma square will follow gamma distribution with rate parameter 1 upon 2 and scale parameter n minus 1 by 2. Right? Now, we want the moment generating function of s square, not n minus 1 s square upon sigma square, right? So what we can do, we can shift n minus 1 and sigma square to the other side. So we can write s square follow sigma square upon n minus 1 gamma half comma n minus 1 by 2. Now you have to understand one important property here. If something is in the multiplication of gamma distribution, we can take that quantity in the division of the gamma distribution of the rate parameter. What is the rate parameter here? 1 by 2 is the rate parameter. And if something is in the division, we can take in the multiplication of the rate parameter. Okay. So this sigma square will go in the division and this n minus 1 will go in the multiplication. Okay. So we can write s square equals to gamma distribution. This rate parameter will be same. Then n minus 1 will come in the multiplication and sigma square will come in the division. And this scale parameter will remain unchanged. There will be no effect of multiplication and division in the scale parameter. N minus 1 by 2 will be the same. Okay, so this s square follow gamma distribution with rate parameter. This one, this is the rate. Okay, and this is the scale parameter. Now, you know that moment generating function, suppose x follow gamma distribution with parameter lambda comma n. Okay, lambda is rate parameter and n is scale parameter. Then what is the moment generating function of x? Moment generating function of x is nothing but 1 minus t upon lambda to the power minus n. Okay, so on the place of lambda, we have this quantity. And on the place of n, we have this quantity. Simply substitute these quantities in this function and we will get the moment generating function of s square. Okay, so what will be the moment generating function of s square? Just simply put On the place of lambda n minus 1, so 1 minus t on the place of lambda, just simply write n minus 1 upon 2 sigma square, and on the place of n, write n minus 1 by 2. Now we can simplify it little bit more. 1 minus this 2 sigma square will come in the numerator, 2 sigma square t upon n minus 1, right? And here it will be n minus 1 by 2. So this will be the moment generating function of s square.